Okay, so for number one, when we look at this, the points do not make any type of diagonal shape. So there's no correlation in that scatter plot at all. For number two, these points make a diagonal shape. When you read it from left to right, it's going upward, so it's positive, but they're really spread out, so that is weak, positive. And then number three, when we read this from left to right, it's still positive, it's still going upward, but they look a little bit more like a line, so that's a little bit stronger. So I would call that strong positive correlation. So great job, everyone. Hopefully you got all of those correct. So for today's lesson, we are going to use a number along with these descriptions. So not only are we going to say weak positive, but we're going to give a number to describe it. Strong positive, that's going to have a number. No correlation, that's going to have a number as well. Okay. So for our vocabulary today, that word is called the correlation coefficient. So basically, it's a number that shows how good the correlation is and if it's positive or negative. So the number is either going to be positive or negative, and it's going to be strong, weak, or perfect, or none. The number is always going to be between +1 and -1. So you guys remember this from yesterday, hopefully. So go to this spot in your 10.7 Google Doc from yesterday. So it's the same exact outline we used yesterday. Or if you're not using the Google Doc, if you're just writing it down in a notebook, that's fine too. Go to this spot where we wrote this down yesterday. So yesterday we already went through this, right? And we said we have perfect positive or perfect negative. We have strong positive or strong negative. We have weak positive or weak negative. And then we have no correlation at all. So underneath of these graphs, we are going to put the correlation coefficient, which is what we're doing today. So it's going to be a number that shows how good the correlation is. So if you have a perfect positive correlation over here on the left-hand side, that means the number you're going to use to describe it is +1. Let's go all the way over here. Perfect negative, that number is going to be a -1. Right? So negative and perfect is -1. Positive and perfect is +1. Now, let's go in the very center. No correlation at all. If it has no correlation at all, that means the number is going to be 0. Okay, then strong and weak are going to be in between. So something that's strong, positive, is going to be pretty close to 1. So something like 0.8, 0.9, 0.7. Okay, so something that's positive and pretty close to 1, 0.8, 0.9, 0.7. Those are all considered strong. Okay, and then strong negative would be the same thing, but it would just be negative. So like -0.7, -0.8, -0.9. Anything that's really close to -1 would be strong negative. Okay. And then basically now we're going to get into weaker. So it's going to be a little bit closer to 0, right? So this weak positive could be like 0.4, 0.3, 0.2, right? So, but it's going to be positive. And then weak negative could be like -0.3 or -0.2 or -0.1. So basically what happens is the closer the number is to +1, the stronger the relationship. The closer the number is to -1, the stronger the relationship. The closer the number is to 0, the weaker the relationship. Okay, so take a second to pause the video here and copy these numbers down, add them to your notes from yesterday. All right, so let's go through an example problem. For each graph below, choose the best R value to describe its correlation. By the way, the variable we used to describe this is R. R is always the variable for correlation. Okay, so let's take a look at number 1. Here's how I like to do it. I like to eliminate the answers that I definitely know are wrong. So when I look at this graph and I read it from left to right, it's positive. So when I look at my answer options, I'm going to eliminate A and B right away because those are negative numbers. So obviously those are not correct for our graph. Now it's between C and D. And that's when I'm going to ask myself, does this look a lot like a line? Yeah, it does. It looks a lot like a line. I would describe this as strong, positive. So which number is closer to 1? It's D. So D is the best correlation. 0.2, that would be a weak correlation. So that's why you don't want to pick that. 0.78 is strong. Okay, let's look at number 2. So same thing. I like to eliminate ones that are definitely wrong first. So when I read this from left to right, it's going down. So it's negative. So A, because A is positive 1, that's definitely wrong. Well, also 1 is when it's perfect. Positive 1 is perfect. Negative 1 is also perfect. So it's definitely not negative 1 either because this does not look like a perfect line, right? So it's either going to be between C or D because they're both negative, but I would describe this as weak because it's really spread out. So the weaker one is closer to 0. So that would be C. That's our better answer because D is negative and strong. Okay, so I hope everyone's with me so far. I'm going to give you another example. Example problem number 2. Match each R value with its correct scatter plot below. So we have 3 numbers, 3 scatter plots. So the way that I like to do this whenever it's matching is I just like to start with the easiest ones first that stick out to me. So when I look at this right away, I say B is the one. If I look at all 3 graphs together, A, B, and C, B is the one that has no correlation. So that's going to be the number that should be closest to 0. So when I look at my list, that means I'm going to use this number, 0.01, right? So always look for if it's strong or weak and if it's positive or negative. It can kind of help you, right? So that one is definitely B because that one has no correlation. So it should be close to 0. All right. And so then now, all right, well, we have this one, which is pretty positive, or pretty negative, but it looks a lot like a line. So that would be negative 0.87. And then this one is positive, and it's a little bit weaker. So it could be 0.56. Okay. So when you're going to do any type of matching, just look for positive and negative and stronger and weaker to help you kind of eliminate them. Okay, one more example problem. So again, I like to look for positive and negative and strong and weak just to make it easier for myself. So it says using the values in the boxes indicate which of the following values of R best describes each of the scatter plots. So it's basically matching again. So if I look down here, this one right here is like pretty, not perfect, but pretty perfect, right? And when we read it from left to right, it's going down. So it's negative. So we want a negative number that's really close to 1. There we go. That's going to be our R value. Now, when I look over here, this one is positive. So I want a positive number that's really close to 1. That one. Then when I look in between here, I have these 3 graphs. This one right here is definitely no correlation. So we got to find a number that is pretty close to 0. So there's that one. And then when I look at my last 2, I have this one to pick from and this one to pick from. So clearly this one is positive and that one is negative. So that one gets positive 7.9 because it looks pretty close to a line. This one is negative and it's weaker. So negative 0.547. And I'm done.